Hello everyone. I hope everybody is back. We'll be starting in another 1 minute, and I hope you had lots of learning throughout the day. We had 3 long hours of sessions back to back, where you would have learned a lot about data science, about different aspects of it. We also got to learn about Google Colab, and now we will be slowly working on some data set, which is a real data set, a data set of Europe, where basically the data set basically corresponds to the number of deaths that have happened through road traffic in Europe across different countries from the year 2000 to the year 2021. So the data set is vast in terms of the number of people who had to sort of lose their life, but we'll look at it from a data science perspective and understand the different kind of visualizations that can be made. And for everybody to access that data set, I'm sharing the link of the data set in the chat. So I request you to have a look at this link and download this file. It's a CSV file which has basically um, short key terms for different countries with the number of years. It's basically the data set is very, I've kept it a simple data set with not much complexity so that everybody can understand the visualizations and try to figure out how this a data set like this, which is a very basic data set, but because it's also over a time period, we can also understand the trend of number of deaths that have gone up or down, or even with reference to countries, how is it in particular region, and how is it like. Meanwhile, can Gerson, can you check if the link is working so that we can start?
Yeah, should I finish the should I finish that data set that I have first and then get to this, or
Sure, you can.
yeah, I was just going to finish the thing that I was working on, and then we can take a look at this. Uh, okay, so this is the one Bakshi's just mentioned, right? And this is real data set, right? This is a real data set. It's only showing me 23 rows. Is there more, or is it only 20? Should be more. No, it's only showing me 23 rows. It's only 23 rows. Is that okay? I guess it's a okay. So this is basically time period every year, number of deaths in each of these countries, right? And so we can look at some visualizations there. But before we get there, I just want to finish this data set, right? So we've cleaned up all of this data. Now there are some other techniques that I haven't covered here that are also important, like outliers. Sometimes you have some data that are like maybe like if, let's say over here, let's say someone who's really good, right, scores a lot of goals, way above average. It kind of skews all of the data, right? Or if they've or very if the numbers are very low, right, way below average, then it could skew the data set. So you wouldn't get realistic visuals of that. So sometimes one of the other techniques used is called cleaning out or removing outliers. Okay, so I will share a notebook with you that goes through the same data set here, this fake data set, and cleans up everything. And in that, I also mention outliers. However, because of time, I won't do that right now. And we will move on to plots. Okay, so now that we've cleaned up all the data, actually, wait, one more thing before cleaning up the data. So remember, we've got the date of birth here, but it's showing us the date of birth as an object, which means like a string, and we would want the date of birth to be a date of type um, date time, right? Date time, because it's a date time thing. So let's do that now. Let's convert. I go to code now. Remember, we mentioned the importing date time. We've done that before, right? So date time now gives the interpreter access to lots more code, right? And then we can, and then remember we did date time date time dot now, right? And this gives you the current time. And this is quite a lot, right? There's lots of date time dot date time, you know. So one of the things you can do is you could say from date time, import date time. Okay. So you're picking up from the date time library. Imagine like the date time is a really big uh, library with lots of like rooms and shelves and whatever. So you're saying from the date time library, give me the date time shelf, the sub thing of that. Okay. And if you do that, now you only need one date time. That would also work. Okay. So let's do this new thing of now date time from date time import date time. Okay. And then what we're going to do is we're going to take this just this date time column. Okay, so let's just look at that. Okay, so I'm only looking at the date of birth column. Okay, and the date of birth column is of type object, and we want it to be of type date time. So PD again, PD is pandas has a function called to date time. Okay, which basically just converts. See, this is the definition here. It's converting uh, a column. You have to tell it which column, right? So here you got to tell it which column to convert to date time. So we want date of birth. Okay, so we're converting the column, only the date of birth column, into the date time data type, right? And if I run that, it will now show me, it looks the same, looks exactly the same, but you can see that D type is date time 64, right? And over here, the data type is an object. So you can see the difference now. And what that means is now you can do a lot of date time type things with it that you cannot do as an object. Okay, but remember, it's throwing back, it's giving back the new date of birth column. And so you have to replace the existing date of birth column with this new column. Okay, so now I'm actually updating the data set. Okay, now what can you do with this? Now that we have the date of time, the date of birth changed into a date time, what can you do? Well, one of the things you can do is you can calculate the age, right? You can calculate how old each of these players are. So how do we do that? Well, the first thing you can do is you can calculate what the current year is, right? And date time, right? Now, so you would say 2024, right? I could just say 2024 here, but let's calculate it, right? So one of the things we want our code to always be, and this applies for all types of code. I tell my team all the time that the code has to be future proof, which means that it should work today, it should also work next year, and it should also work the following year. It should work any year. So this is what makes it future proof. If I put 2024 here, it's not going to work next year because next year the year is 2025. So I got to go date time dot now and then year. So I want the year okay, so the year and then okay, so it's 2024, but it's calculating the current year. Okay, so I've got current year. Now what I can do is I can say current year minus, and this is the beauty of pandas, right? So here I'm minusing, I'm saying 2024, which is an integer, minus, and I'm minusing an entire column, right? So the entire column of date of birth, okay, but not not the entire part of it, just the I just want the year part, right? So how do I do that? Dot dt, which give me the date part of the date of birth. Right? So let's see what that looks like. It's the date part of date of birth, which is an object. So nothing much we can do there. And then the year part of that date. Okay, so now it just gives me the birth year of everyone. And now if I go 2024, or not date, current year, minus, okay? So the current year minus that, I get the age. Now it's not exactly accurate, obviously, because it depends when their birthday was and all that. But it's close enough. We have an approximate year, approximate age is what we have, right? So now we can say D key. Now we're adding a new column. This column doesn't exist. EF, sorry. Age. We're adding an age column, and we are setting that value to this whole thing that we just calculated. Okay, which is done. And now if I go all the way to the top, right, df.info, watch two things I wanted to watch. One is we've added another column, right? So now there are, instead of 10 columns, there are going to be 11 columns because we added age. Age didn't exist before. That's the first thing. Second thing to note is date of birth is converted from object to date time. Okay, so I'm going to run that and pay attention to both those things, right? Look at that. Date of birth is date times 64. I don't worry about the 64 in all of these. And then the age is int 32. Again, don't worry about the 32 and the 64. But you can see that we've added a new column called age, and the date time is date of. Okay, so cool. So now we're ready to visualize some data. Okay, so now I'll just talk about visualizing data. So again, remember, our interpreter is very smart and knows a lot of things, Python interpreter, but every now and then it needs to consult someone or pull in external resources, right? Import some external resources from a library or whatever, right? We've imported date time, which is important. We've imported random. We've imported pandas, and now we're going to import another one, which is called plotly. Okay, so import plotly, and then plotly is basically it's to plot charts and all that, right? Now plotly again is a huge library, right? So it has shelves and shelves and shelves. You can think of books and resources and all that. So you got to go dot, and you got to go within that, right? So you've got widgets, you've got data, you've got, look at that, lots of stuff within that. And what we are interested is in something called Express. Here, okay, we care about Express, and Express means we're going to have very basic code to create very powerful graphs. Okay, and this is such a big name, plotly.express. We're not going to say plotly.express all the time, so we're going to say as px, right? Plotly and express. We just call it px. Okay, so run that. That's fine. And then the other thing we can do is we can so the first, let's see what the first plot that we're going to do is the top players by goals and assists. Okay, so that's what we're going to visualize, the top players by goals and assists. So we have two columns. We've got goals as one column, and we've got assists as another column, right? And we want to see the top players, and the top players are determined by adding the goals and the assists, both of them, right? So we're going to add now another column. Oh no, let's calculate first, right? So we've got df goals plus df assists. Okay, so if we add both these, we get another column with the addition of the goals and the assists, right? So this is for every row, it does that calculation. And it's throwing back the calculation of the result. We got to catch it and store it into a variable. And we're going to call the variable df, let's call it totals, right? Let's call it total. Okay, so now we have a new column called total, and you can check if I run this info again. Now there'll be a new column that says total, which is of float type. Okay. Okay, cool. So we got that. The next thing we want to do is we are ready to create a figure. It's called a figure, right? And you can call it again. It's a variable. You can call it whatever you like. Fig is a common term for that. We're going to go px dot bar. Px is, remember, the Plotly Express library. And then inside that, there's a dot function called bar. Okay. And the bar takes in the data frame. Right? So we give it a data frame, and it takes a data frame. And what it's telling me here is that it's not enough. It needs more information than just the data frame, right? So, so what else does it want? It needs to know, for a bar graph, it needs to know what the x-axis is, right? And it needs to know what the y-axis is, right? It needs to know, obviously, if you're plotting a chart, you need to know what the x and the y is. So on the x-axis, is down here, right? We're going to go with the name of the player, right? Name of the player. And on the y-axis, we're going to go with, so there are a couple of things we can do, right? We can go with total, what we just calculated, right? And we plot that now, see if that's enough. Maybe it's enough, maybe it's not enough. Oh, it's enough, but one of the things with Plotly and also other tools, there are other tools as well that does this, is you have to say fig.show. Okay, so once it calculates it, then you show the graph. Look at that, beautiful. With just one line of code, right, we're able to plot a beautiful graph, and it shows me the name of the player here, right, and it shows me here, it shows me the total number of goals plus assists, right, on the top there, right? Beautiful. Okay, so now one of the things is, like, although this is helpful, and note what happened. I increased the size of this, and it made it like slanting, right? So it's easier to read than horizontally. Okay, so yeah, so good. So now let's clean this up a bit. Let's improve and make this chart even better. Okay, so the first thing I want to do is I don't want like it's all jumbled up, right? Some are big, some are small, all of that, and I don't even know what order this is. It's in a very mixed order. So it would be nice if we could sort the data frame by the total. Okay, so you can see, so we can get them by this new column called total, right? So let's sort it by that. So how do you do that, right? df, okay, we see df all the time, and then there's a function called dot function called sort values, right? And then positional argument, not positional, named argument, by sorted by what? By the total, okay? And then you want to tell it ascending or descending, and the default is I think it's descending, ascending. So it's ascending, starts with 1, goes all the way to 4. Okay, and then you save that, you catch the result, and then you save it under df. You could overwrite it, but let's not overwrite it. Let's create another variable called df sorted. Okay, so we have df sorted now. And now when we generate the plot, let's use this new df sorted uh, data frame. Okay, and let's show that now. You can see now it's all sorted, right? So you have starting with the smallest, and it goes all the way to the end, right? But generally, graphs are not this way. It's generally like top to down, right? You start off with the highest, and then you go all the way down. So how do you do that, right? Go back to this sorted, and there is another positional argument called ascending. Okay, and the default is true. It sorts it ascending. Smallest first goes up to the biggest. But if you put false here, then it's going to sort it in the opposite order, like descending. So done that, create the chart again, and then render it. And there you go. So now you have it in descending order. Okay, let's keep improving on it, right? So the next problem is that it's got all of the players, right? It's like, well, I don't care about all of the players. I only want like maybe the top 10 players. I only care about the top 10 players. Okay, so how do we do that? If we go to a new code again, and we say df sorted dot head, right? Remember we did head right at the top over here, df dot head, and it just gives you the top 5 values, right? So if I put df sorted dot head, and they're sorted in descending order, I get total is 50, 42, 37, 33, and so on, right? So that's basically what I want. BF sorted dot head, except that it's only giving me 5 here, and I want the top 10 values. So head also takes in a number, right? The default number is 5, but I can give it a bigger number like 10, and now it will give me the top 10 values, right? Which is what I want. I want the top 10 values. And again, like all of the others, it's throwing me the result, and I need to catch it and save it into a variable. And I'm going to call that top 10, BF top 10. Okay. And then I'm going to now change this so it's sending the top 10 data frame. Okay, not all of it, only the top 10. And then let me show that. Look at that, beautiful. So now I've got the top 10 performers, right? The top 10 performers, much easier. I can make more sense of it. Okay. All right, let's clean it up a little more, right? Often these graphs have a title, right? A title on top of it. It would be nice if there was a title there. Okay? And then before I do that, you'll notice that now this is getting, remember I said parameters, you could have 10, 15, 20 parameters. So here's an example where it's getting bigger and bigger, right? So we've got 3 and now we want to add another one. And so a better way of doing that now is I go to the beginning here and I press the enter key. And I can list all of these one below the other, okay? So why? And then the next one is title. I want to give a better title. And I want to say, what I want to say, top players by goals and assists. Okay, that's a better title. There's no title right now. Let's give it a title. Okay, so let's run that and then show. Okay, so now I have a beautiful title over here, right? Getting better, right? Okay, another problem. Okay, um, the labels over here, we've got total and we've got name. Okay, would be nice if name doesn't make sense. Would be nice if it had player over here, if the value was player over here. And over here, if we had, if it was called, what should it be called? I think total is fine over here, right? But let's change this to say player. Okay, so how do you do that? You add another parameter. So we've got lots of parameters, and this one is called labels, right? So we want to access the labels parameter. And now we're using something called a dictionary. We haven't done dictionary before, but it's not square brackets and it's not regular brackets, but it is curly brackets, right? Like this, like how we have F strings. Okay? And how a dictionary works is it has key pair values, right? So you have a key and then a value. So the first thing here is what do you want to change? So I want to change name, right? I want to change name, and I want to rename it to say player. Okay, so if I run that now, okay, it's going to give me now player. Okay, so I've got total there, and I've got player. Okay, so one more thing. Let's try and improve it even more. On the Y group, instead of giving me the entire total, I could have the total, which is fine. I want it to be broken down into goals and assists. I want to see which of these are goals and which of these are assists, right? So how do I do that? Okay, so the Y axis here has an option to put in a list. We've seen lists, right? And instead of total now, even though I created the total, I'm actually going to provide the goals and the assists as two items in this list. Okay, so now let's see what we can do if I provide that. Right, look at that, beautiful. Okay, so now I've got player, I've got blue. It tells me over here, blue is goals, red is assists. Right, beautiful. Look at that. So now I can see that this had more goals and less assists and so on. Right, this one had only goals. This one had more assists than goals, right? So you can tell all of that more information here, right? And it introduced some more problems. right? So we've got like now this says value here, which is like what do you mean value, right? What I'd like it to say is number of goals and assists. Okay, so I can go to labels over here, and I can put a comma at the end, and then I can create another one of these heads, right? So a string, a colon, and another string. Okay, so the first value here is what do you want to change? Value, right? I want to change this value, and here it's what do you want to change it to, which is number of rows and assists. Okay, if I run that and then run the show the figure. Okay, so now you can see number of goals and assists. Beautiful. See, it's all getting better and better, right? Very, very presentable. And so it's so easy to do this. You can do it with any kind of data set, right? One last thing here. You see that there's a thing called variable over here, which doesn't make sense really. We want to change it to, let's say, type, right? Type of goal or assist. Is it a goal or is it an assist? So let's do that now. Let's add a comma, add another one of these pairs, and I want to change the variable to type, right? Run that, run that. There you go. Beautiful. See that? So I've got uh, most of these. Um, yeah. So there you go. That is this uh, one plot. Okay. And I will do one more plot, and then I'll pass it over to Bakshish. Okay. So this one is goals by team. Okay, so we'll have another plot here, which is goals by team. Okay. Okay. So in order to uh, calculate the goals team, you have to group them, right? We have to group the the data frame by the team. Okay, so let's do that. df dot, again, all of these start with df dot, and then we're going to say group by. Okay, and group by what? So it's a function, like we have a function, and then we're saying group by team. Okay, and so if we run that, it gives us an object which is not viewable. So we need to be more specific here, and we care about goals. We care about the goals by team, right? And again, this would probably be, yeah, another object, and then so this is aggregate data, right? So I'm grouping them by team. Then I'm taking the goals column for each team, and then I'm going to sum it. So I'm going to add them all up within each thing. Okay, and now it makes more sense, right? So I've got all of the teams here, and I've got the goals for the entire team, right? So it adds up the goals for each team. So Real Madrid had 33, Roma had 8, and so on, right? So that's what we want to do. And now that we have this data, let's put this again. It's throwing back something, and we want to catch it and give it some data, right? So we're going to say team goals equals all of that, right? So now we have a new variable that we can work with. Okay, so now we go fig or figure. You can call it whatever you like. Px dot, and this time we'll use uh, another type of graph. And Bakshish has a lot of examples of other types of graphs. I'm going to show you two graphs, and he's got samples of even more types of graphs. Okay, so the first thing is you need the data set, right? So the data set is team goals. Okay, that's the data set right here that we calculated. Okay, and a good time is see if it's enough. It probably is not enough, or maybe it is enough. Let's see. Fig dot show. Okay, nothing, right? So not enough information. We got to give it some more information. Okay, so the first thing is we need. Actually, let's see what this looks like. Team goals. Okay, so we've got team, right? There's only one column there, and we need to pass that. So names equals team. Okay, not enough. Need some more information. Uh, So one of the things you need to do is you got to reset the index because uh, so now you have the right columns, right? If you before I did that, you saw that there were no columns. There were no columns there, which was causing a problem. And I won't get so much into the index thing, but basically every row has an index, and when you group by something, then it gives you back a data frame, but without any index. And these kinds of charts need an index, so that's why you have to put reset index. Okay, so now I have some kind of distribution. Okay, everything is 5%. Looks a little weird. Okay, so let's keep working at it. The other thing it needs is it needs to know what the values are, right? So theme is the names that we got that. And if you don't provide values, then it spreads it equally. So we want to give it the values column, which is goals, right? So goals, okay, and run that. Okay, looking better now. So we've got all of the themes over here. That's the what's it called, the labels, right? And then we have the thing over there. And see, it's very just with this little code here. Look at what we got, right? You can hover over it. You can see the theme and the goals, right? You can even check and uncheck, right? Let's say you don't want to see all of these. You will care about some themes, right? So I'm unchecking some of these themes, right? Look at that. It shows you whatever's left. Like it only gives you the ones that are left. Okay, and then you can do the normal thing. You know, title is what? Goals by theme. Okay. Um, and then you could have labels. We don't have any labels over here. So let's add some labels. Um, okay, so here we're talking about this label over here. See that? See that pop up there? So now you have team name, and then instead of just goals, you could have total goals, or you can just leave it as goals. Doesn't matter. Okay, and then the only other one more thing I will do here is there is something called you can, let's say you want the top three of these to be pulled out, right? You want to percent plus label. Okay, so update traces. That's another thing over there, and the text info is percent plus label. And so what this does is it also gives you the, why does it have it twice? I guess this fig.update cases also shows the chart. Anyway, so this gives you like the actual percentage 9.02. It tells you the percentage, and it tells you the label of what what is it? What is the team name? Right? So it tells you that as well. And for if it's really small, then it shows it to you in this way. Right? So lots more interactive. Okay. Uh, okay, so that's all I have. And then finally, when you're done with all of this, maybe you want to save it because you've modified it and you've done a lot of work and you want to save the file. That's what you normally do. Okay? So you can say df.tocsv, right? And then you just give it the new name. So you can say clean data.csv and run that. And you can see now I have a new file called clean data. So I will be sharing, I have all of this on a nice Jupyter notebook with explanations and all of that. So I'm going to share that. I think we'll collect all of this and put it into one Google Drive and share that whole thing with everyone. Okay, so there's lots of things to share. Bakshish, I am done handing it over to you.
Thank you. Thank you, Gautam, for explaining. So I'll now start sharing my screen and show you what we are going to do with the data set that we have. So I hope you can access the data set that was shared earlier. I'll share my screen and show you
Yeah,
the data set as well.
we can access. We can access.
Okay. Mm, Yes, so this is the file that we have, and like before getting into doing the visualization, I would just like everybody to see the data that we have longitudinally, basically from along the length and breadth of it. So we have a time period from the year 2000 to 2021. This data is derived from Eurostat. I hope some of you would be aware of Eurostat because a lot of data about Europe is, I mean, this is where I found this data from. And these are keywords for the countries. And I also have a file which has full names of the countries, which I would also add in the folder so that everybody can access that. Meanwhile, I will start sharing my screen on the Google Colab file so that everybody knows where we are starting from. So I am now sharing the link to Google Colab once more in the chat. And yes, now I will share my screen into Google Colab. I hope the screen is visible to everybody. Is it visible?
Not yet. Not, not yet. We can see it.
Okay, you can see now.
Yes.
Yes. So once you reach here, now as we had already done Google Colab a little bit, but I'm starting from scratch so that people who are starting to also download the data. So we go and click on new notebook. Once the new notebook opens, now the next step would be to upload the data that we have. So the task would be to download the data file that was shared earlier. We will name the file as Europe Road Accident Deaths. And once we are here, so you'll find that at close to center left, you'll find there's a file section. We would go and go to the file section where it would say it. So it shows that it's connecting to a runtime to enable file browsing. So once this is done, you would be able to see that you can upload the file over here. It's loading a little slow for me, and it's not showing me. Just a second. So basically, once you have this open, task would be to upload the file here. And I'll just refresh my file. For some reason, it's not allowing me to upload. Yes, now it is. So you'll see the option here to upload to session storage. So over here, I'll get an option to upload, and here I upload the file. It shows that we need to the file gets deleted after the runtime once it's uploaded. So what I have done, I have already done a few visualizations on this data set in a separate file, and I'll be using the same code which will be shared with you after the session, and you can use the code to basically do those visualizations. To start with, we'll just import a few libraries as it was also shown by Gerson earlier. So I'm importing 4 key libraries: pandas, numpy, matplotlib, and cbon. And then, as you can see, in after hashtag, we basically load the data set, and this is the name of the data file. And we are asking Python to show the first few rows of the data that we have.
So wait, hold on. One of the things to mention here is so he's got matplotlib and seaborn, and so these are three different visualization libraries. So the one I used was Plotly, and these are the other two very popular visualization libraries, matplotlib and seaborn. And so they all do very similar things. So keep that in mind.
Yes, thank you, Gerson, for highlighting that. So next, we will be starting with some basic level of code, like basic in the sense that we won't. This is not visualization, but this is just some important codes that you can also use somewhere else for some other data set, depending on the kind of data set that we have. So we are starting with these. So this is the first one is basic information about the data set. The code, I mean, it's there. Then second one is on checking for missing values. Third is on summary statistics and then duplicate rows. Now we will run this code. So once we run it, it shows that there are no missing values for any of the data columns that we have. So as you can see, for all the countries, there's no missing value. So we are sure of that. This is something which is important. But interestingly, you will see that there are three missing values for United Kingdom, which is an important point, which we otherwise might have ignored if we would have not run this code. Second, now we see summary statistics. So summary statistics basically gives us a summary of things. So for example, the count, mean, standard deviation, 25 to 50. So this is basically it represents the data, how it's being represented for different countries. And you can see that we also have all the countries being mentioned here. I'm rushing a little bit so because we have important visualizations ahead, and I'm sure you are all also excited for the same. Yes. Now moving forward, so this is the now we are going to the visualization correlation matrix code. So again we go add code, and here we paste the code here and we run the code. And once the code is being run and loaded, we have the visualization. Yes, I hope you can see the heat map. So this visualization is called as heat map. It's not very applicable for this particular data set, but the reason I am doing it here is because heat maps are otherwise very useful for different kind of data sets that like as data scientists or potential data enthusiasts will work on. So this is how it's also very useful. You can find it for other data sets as well. We'll be working on some other data sets tomorrow, or probably in your future practice of data science. You can use these codes. Hence, we are using these. So now next we are going to do an outlier detection using box plots. So an outlier detection basically helps identify if there are any outliers in the data set that we have. For some reason, wait. Let me just correct the code here. Mm, wait a second. Yeah. Yes. Yes. Here we have. So this basically this code was of visualizing the trend of deaths over time in different countries. So as you can see from the year 2000 till 2020, we have different countries and the number of deaths that are there. So the x-axis represents time period and the y-axis basically represents the number of deaths. And we can see different colors that are labeled for different countries, which basically helps us understand which are the countries which have highest number of deaths, or how is the trend going on for the same. Now moving forward, so now we'll move to a, basically this was a table. Let's say that imagine you have the same table, same data set in a table in Excel, but the like you need to apply your brain to understand which countries have higher number of deaths and which countries have lower. So this one is basically, this visualization is a heat map of traffic deaths. So in this, as you can see, we have some countries which have a blue color and some countries which have a yellowish light yellowish color, and some with a little greenish tint as well. For which we have the legend on the right, which basically highlights the how the number of deaths is basically correlated with the color that we have. So as you can notice, Germany is a dark bluish color. Similarly, France. Similarly, Italy. But also something to notice here is the trend that these number of deaths are decreasing over the years. As you can see, in the year 2000, we have highest number of deaths for a lot of the countries, while it is slowly going down as we are moving to 2021. So this is a trend that we are able to notice because this heat map of different traffic deaths, different deaths due to traffic, is basically helping us as viewers understand how these deaths have decreased. So this could also be attributed to more traffic-related regulations by the different countries. It could also be more safety-related technological interventions being made by manufacturers such that cars are more safe, so less number of deaths are happening because of that. There could be anything, but this over a period of time, since we because we are able to see, we can if we are able to draw some correlations. That's how these maps are helpful. And otherwise on Excel we'll have to do, like, we would be required to do a different kind of analysis to figure these things out. Now, going to the next category of diagram. So basically, next we'll be seeing this across a violin plot, which is Seaborn. So this is the code for it, and now you'll see that how different countries are basically being shown in form of a violin plot. Yeah. So as you can see, a very high number of deaths is visible in countries like Germany, France, even Spain, even Italy, and Poland as well, along with followed by United Kingdom, Romania, and Greece and other countries. So these are different kind of the idea of this is basically so that you know the kind of visualizations we can do on Google Colab through Python, and these are just like different ways that we can do these visualizations to express any kind of data that we are using for these visualizations. Now, next we would be doing a pie chart to understand the different percentage values for all these. So let's say that we don't know how much percentage of deaths are there across different countries. So now, basically, this one is something which is also further more dynamic, because right now we are seeing the traffic death proportions for the year 2015. Now, the most interesting part about this particular code and this particular visualization is, if I mean, it's even possible for earlier code files, but this one is much like you don't have to change the code much. So right now it is 2015. Let's say I want to do it for 2008, and now I've changed from 2015 to 2008, and now if I change the code, I mean run the code again, it would show me the data for 2008. I hope the figure is visible completely. Yes. So now it's visible for 2008. Similarly, if I want to see change of proportions, let's say 2018. So right now we see that Spain mm, has anywhere close. So let's say Italy has close to 12% of out of the total deaths. France has 10.8. This is 2008. Let's see how it has changed over the next 10 years in 2018. So Italy has moved from 12% to 13.2%, while France has come to 12.9%. So this way we can get such pie charts for different years, and these different years can then we can see the trend, how the trend of number of deaths on road accidents is moving across the time period for different countries. I hope this was clear, and everybody is able to see the figures clearly.
Yes, very clear.
Great. Now, moving forward, I would basically now do a stacked bar plot for different countries and the number of. So basically, this stacked bar plot can be useful for comparison for only specific countries. So yes, so right now for this one, I am doing an analysis for Germany, France, Italy, Poland, and United Kingdom. These are the countries that I have selected, and we can change these countries. Yes. So as you can see, now this represents how in a particular year which countries have higher number of deaths due to traffic, due to road accidents, and the different colors represent different countries, and this is a stacked bar plot of the traffic deaths over time for these countries. So let's say now we would like to change from replace France with Spain, and Poland with Portugal. Yes. So now we can see how, so similarly, we can change the countries and see. So as you can see, Portugal has very low number of deaths across the entire, all the years that we have. And one more thing to notice, after 2018, we don't have any deaths visible for United Kingdom. So, as while we began working on this data, we saw that there were three null values for United Kingdom. So, because there's no purple color on the top of 2019, 20, and 21, it does not mean that there are zero deaths in United Kingdom due to the road accidents, but because there's no data available for that. So that's also something when we are doing such visualizations, it's important to note how we can find these small things in the data. And as you can see, we can change any countries, replace, for example, let's say we replace Germany with Estonia, because I believe there are some participants from Estonia in this, in our session as well. So let's say we replace United Kingdom with France. Yes. So now we have, yeah. So one interesting thing to note: there are very few deaths that we see in Estonia. It's at the bottom, the slightly bluish color that's there at the bottom. While there's, we see again Portugal also little number of deaths, with the higher proportion that's visible for Italy and France. So this is a stack bar plot which can give a great, it can help us compare for different variables. These countries are just variables in this case for us, and this can be any other kind of data set where this data, I mean, there can be some other point, important data which we are using, and we can do such comparisons. Now we'll do a bubble plot for different countries. And so in this case, right now we have a lot of countries, but like the bubble plot is generally used when we are having lesser variables, but it's important to see and also understand what a bubble plot looks like. So yes, as you can see, this is a bubble plot. And the right now, so earlier we had a stacked bar, so the bars were showing the number of deaths with reference to how big the bars are. In this case, a bubble plot, the size of the bubble tells us the number of the deaths that we have due to accidents in this case. So as you can see, a very high, we can see a very high bubble for Italy, similarly a very high bubble for Germany. Similarly, let's see, where is France? Yeah, a very big bubble for France. For Portugal, yes, we have Portugal, a smaller one, and the size is reducing. Similarly, same goes with UK. One common trend is that for all the bubbles that we see, the size of those bubbles are reducing, which shows a decrease in the deaths due to road accidents across Europe in different countries, depending from country to country. Yeah, so this was a bubble plot. Now let's slowly move forward to a radar plot. Radar plot is one of my favorite visualizations because it gives an interesting radar kind of a visualization. And yes, so even for radar plot, we can also use different kinds of different years. So this is how a radar plot looks like. So it looks like a radar where the number of deaths that we have, it can be attributed at the peripheries of the circle where each country is represented. So as you can see, France, Germany, and Italy along with Poland, is one of the highest in the figure, while which is this is followed by United Kingdom and others. So right now for this plot, if I want, I can even change the year from year 2000 to, let's say, 2015, and run it once again. Now, yes, so now it's giving us for 2015. So this way, it's really helpful to understand again and give a holistic overview of, like, to identify the countries which has higher number of accident deaths. And we also have the numbers 500,000, 1,500, 2,000. So this basically gives a range for the viewer to understand what is the range in which the number of deaths due to road accidents are there. So yes, we can also change the minor aspects of it in the code, like which is basically the angles or the color that we have. So these things can also be changed in the code. Just as a last change, I'll check it for the year 2010 as well. Yeah, so this is 2010 again. Now this time, again, Italy, France, Germany, Poland are one of the highest ones, and others are then followed. So slowly now we would also be moving to some very interesting visualizations which have maps of the countries. But before that, one last visualization that I would like to do is of a stacked area plot. So an area plot, you may have seen it for used for GDP, often by different news agencies, but we'll now see it for a set of traffic related deaths. Yeah, so this is a area plot for deaths over time. So as you can see, overall the number of deaths have decreased significantly. We can see it from the total number of deaths that is there at the y-axis, and the x-axis representing time. And again, it's clearly visible the names of the countries which have higher number of deaths, which is Germany, France, Italy. Now, next, slowly would like to go ahead and do a Boxen plot of different countries. And also, please feel free if you want to stop, and if you want to see a visualization once more, in case there's anybody who requires to. Yes. So now this is a Boxen plot. So this represents different countries with reference to the number of deaths again. So again, similar response, but a different kind of a visualization. We are able to see the countries which have a higher number of similar countries are there: Germany, Italy, Poland. So a different kind of visualization, and the need for the visualization would depend on which visualization should be used. So now I'll just do a last few set of visualizations which are more GIS focused. So the idea is for the students to see and understand the potential that Python or data science as a domain has with reference to the visualization. So for this one, we are using the library called Folium. That's why the starting of the code, it mentions import Folium, and Folium is primarily like it's used for GIS and map related visualizations. Yeah, so now we have a map in front of us. So as you can see, now it's it's not just stacked bar or pie charts or those stat visualizations. It's a map, and we can move around on the map depending on which country that we would like to see. So for example, if I go on Germany, it shows me the average number of deaths. Similarly, if I click on Poland, it shows me the average for that, and for Italy, for France, for UK, and I can just change the title of the country that I would like to modify, and we would get a visualization for that as well. Let's yeah. So because this would also just to also one important part to highlight for students, it would also require us to give coordinates of the countries. So that's how, because we can also add more countries in it depending on how we would like to, but we would need to have the latitude longitude coordinates for it, where the dot for the country would be mentioned. And this is done through Folium again, like I mentioned. Now a last few set of visualizations on GIS. I think, yeah, this is so this is the last one that I had with a map, and otherwise, as we had covered a lot of other visualizations which we have, I also wanted to cover a few basic concepts of machine learning. But I think in the interest of time, it would be better that we could look at it tomorrow, and just probably go through the visualizations once more. I'll just scroll through it as a revision, and then I'll hand it over to you, Gerson, for the last 15 to 20 minutes that we have kept for any questions or any other comment that anybody would like to make, and Gerson, that the initial point that you wanted to add at the end of it. So yes, so now I'll just run through what all we covered. We covered, so through Folium, we covered map-based visualization of different countries with their deaths. Then we covered a Boxen plot. We covered a stacked area plot of deaths over time. We covered a radar plot. We covered a bubble plot. We covered again another stacked bar plot, which is basically useful for comparison of different deaths for different countries. We covered pie chart. Again, we can modify it for different countries for the different years that we are doing our analysis and compare it. We did it. We did a box plot for a violin plot for different countries once again. So then we covered a heat map with different countries and the colors to basically represent the number of deaths, and the higher number of deaths being represented with blue. Then this is a trend chart where we have different countries being represented, and it's good to see that the trend is declining from 2000 to 21. A correlation matrix map, and this is where we started from, our summary statistics and our missing values along with the data upload part. So I know I went a little quick with reference to these data visualizations, but the idea was that for students to see and understand the potential of Python with reference to what different kind of things can be done. So yes, here we are, and yeah, I would like to hand it over to you, Gautam. You can take it forward.
Thanks, Bakshish. Okay, so we've got we are coming to the end now, and I'm wondering if anyone has any questions. And so there can be any kinds of questions. It could be questions about what we covered today. It could be general questions. So if I can help, I'll be happy to help. So I've worked with software a long time. Worked with software developers, worked with teams, worked with companies, worked with all kinds of projects. So I've experienced quite a lot of things. So if you have any questions about just software in general, in the professional world, and different uses of programming, different departments, all of that. If you're thinking of pursuing a career could be in coding, could be in other things as well. There is an aspect of technology in almost all areas. Also, artificial intelligence and machine learning. If you have any questions about that, it started trending a couple of years ago. If you're curious to know how that impacts various things, right? So school, university, offices, software teams, it's very interesting. I've got lots of very interesting things to share, but only if you're interested, I can go into that. Otherwise, you're wasting people's time. So yeah, open Q&A, any kinds of questions.
May I, Gautam? You mentioned very initially about a few things which is like a little slightly unrelated, but I'm sure that a lot of curious students in the class would be interested in. You mentioned about Web 3.0 taking over, and a lot of, like, you mentioned about Solana, and how these new technologies, blockchain and others, have sort of have come in as a transformation in this sector. So if you could shed some light on the work that I mean, how Web 3.0 has been impacting the work, both positively or negatively, and if you could also shed some light on how people who are new in this domain can enter Web 3.0, or even sometimes when people are not coming, but are not familiar with Web 2.0. So how would I mean, how the space is changing?
Right. Yeah. Good question. So let me cover some broad topics on this, right? So there was a book that came out a couple of years ago called Read, Write, Own, right? Amazing, amazing book to read. And it talks about um, the evolution of technology from a high level perspective. And we're talking specifically about the web, right? So we have Web 1.0, 2.0, and 3.0, and that's how the read, write, own comes in. Right? So read is Web 1.0, write is 2.0, and own is 3.0. And so a little bit of history now. Maybe some of you are old enough, and maybe some of you are not. But life in the olden days, when I say olden days, I mean in the 90s, the 80s. Um, when the internet just came about, right? So there were very limited things you could do. So there were some websites like Yahoo and you know Geo Pages and Stella Vista, and there were some few websites, and these were really really big companies, and they were the only ones who could afford to have websites. It was very difficult to get a website in the first place, right? So most of the people, the average person, all they could do was go to a website and read it, right? Read news articles, read newspapers, and that's it, right? I couldn't uh, put out anything onto the web, right? I could send emails, but that's private, right? So I couldn't really post something publicly, right? And then there came the world of write, right? So I think MySpace was one of the first few that were in that technology. You had Yahoo groups, you had all of these, and so this was like the first time you could actually publish something. You could actually write something and put it out there for the world, right? And then of course, Facebook is what took off that whole, led that whole Web 2.0 mission, you could say, right? And so people could do lots of things, right? You could publish your own things, you could publish your blogs, you could publish YouTube videos, you could record your own videos, you could do all of these wonderful things, right? The only problem is that you don't own that information, right? You've created it, you've posted it. So let's say Medium or Blogger or YouTube or Twitter maybe. It's not owned by you, right? It's owned by an organization, right? By Microsoft or Twitter or Medium or whichever the company is, right? And so that's a problem, because if uh, for whatever reason, if they don't like what you're doing, they can block your account, they can delete your content, you can cancel you. We've seen a lot of that in media, right, recently. And so you don't really own that information. And sometimes it's fine. You may say like, oh, I don't really care about, I'm just posting updates on Twitter or whatever, and Instagram, and that's fine. But other times, you do have important information to put out there, right? Like confidential information. Maybe it's proprietary. Maybe it's a business idea you have, or whatever. And so that's the limitation with Web 2.0, right? You can put things out there, but you cannot own it. Right? And when I say own it, I don't mean legally. I don't mean just legally own it, right? I mean like uh, own it so that governments and big companies cannot steal that data from you, right? And so that's when Web 3.0 was born, right? So Web 3.0 is called is that's why it's the own part, read, write, own. And so in Web 3.0, another concept is called decentralized, right? So decentralization of power. Okay, so you're not giving power to one big company, right? And so cryptocurrency also, with Bitcoin, one of the attractions of Bitcoin is that the power is not on banks. Like let's say you have whatever your money, your life savings are in a bank. If the bank shuts down, your money is gone. Right now, of course, uh, for most countries, if you're living in a stable economy, that doesn't really happen. But it is technically possible, right? And so with Bitcoin, you're not. There is no one organization that owns that information, right? It's a network of millions and millions of computers all connected to each other that that have that information. So if you put something, for example, if you put something on the blockchain, right, it's on thousands and thousands of computers. So even if one computer shuts down, right, that information is still there on thousands of other computers, right? So to take down your data is it could be very difficult, right? You got to take down thousands and thousands of computers. So that's the power of decentralization and Web 3.0 and things like that. And along with that also comes other trends, right? It's making it possible now. In the company I work for, it's called Dow Street, and one of the things we do there is it's not just about the blockchain, but it's this philosophy of decentralization. Right? So decentralization is where you don't need to work for a big organization in order to be successful in life, right? Uh, there are there are some other trends. These are all trends which have been coming in the last 15, 20 years, let's say. Another trend is crowdsourcing and crowdfunding. Okay, so crowdfunding is you can see you have GoFundMe, you have Kickstarter, you have Patreon, you have Buy Me Coffee. You must have seen these all over the site, right? So instead of the traditional way where one employer pays you all of the money, now you have lots of people pay you a little bit here and there, cents, maybe dollars, $2 here, a few euros here, and collectively it becomes an income, right? So you're not really dependent on one big company. Now you're dependent on multiple people. So it's kind of like decentralizing. Same thing with crowdsourcing, right? With open source projects, and I would encourage you to join open source projects on GitHub and try and if someone's working on an app or something like that. There are also Python uh, open source projects out there. You can join that for free and contribute, right? And so that's the other thing, right? Crowdsourcing, you're sourcing your information, you're sourcing resources and all of that from thousands and thousands of people, as opposed to just one, a few people or a single computer company, right? And there was a time where the top languages that the companies had for software were proprietary, right? You had to pay for that. And then now with open source, right? Open source, you have millions, thousands, even millions of people contributing towards code, contributing towards whatever it is. Right? It doesn't have to be software, but it could be anything, right? So you have all of these trends in the early 2000s and blockchain a little later, all coming together. And and now we have AI. We've got like another era of AI. And so it's a very interesting time to be in. And
Actually, Gerson, I'm having some problems of connectivity. But before I get out, I just wanted to highlight that in this seminar, we have realized in this
I think you went on mute. Can you would need to unmute once again? Yes, yes. Now you're audible. Oh,
can you repeat the last 10, 15 seconds?
Yeah, I was just saying that we have learned that all these technologies are quite relevant.
Okay, you're mute again.
When we are going to introduce artificial intelligence, that is the one that we have covered less. So it would be good to have your inputs also for that event in June 2025.
Nice. Yeah. So artificial intelligence, and one of the things is, of course, when we talk about artificial intelligence, we've seen some of the examples here, and it's mostly on machine learning, right? Data visualization, that, and that is one aspect of artificial intelligence. Uh, the thing that blew up 2 years ago with ChatGPT is a branch of artificial intelligence called natural language processing, right? So it's the ability for machines to understand patterns, recognize patterns in the world, in the real world, specifically linguistically, uh, and then uh, uh, and then kind of like recognize meaning out of it, try and understand, quote unquote, understand, and then respond with something that's meaningful, right? And so that concept was just amazing. It just brought everything on a whole different plane, right? And that is natural language processing, and then other things followed up, right? So they have image recognition, image processing, image generation, and things like that. Audio speech recognition, text to speech, and so on. Right? So we have all of these families. All of these fall under the category of artificial intelligence. And so in my company, we're trying to be as cutting edge as possible, but at the same time, we're careful and about security, and we have to be responsible. And I give a lot of seminars on the topic of AI awareness, and so I'm looking forward to this. I think in June you mentioned uh, on the focus is on AI, and one of the things I mentioned there is that we have to be responsible when using AI, no matter who you are. You got to be responsible, right? So as a student, for example, and that goes for me too. If I'm learning, and I do learn, there are some languages I'm learning right now, new languages, and so I avoid using AI for that, right? Because I don't really learn. If AI is doing all the work for me, if AI is doing all the thinking for me, then I'm missing out on the important part, the process to learn, the process of learning. So if you use AI for learning, and it's not just for software, it's for anything. Let's say you're supposed to write an essay in university, and you use AI to do that, right? You're kind of outsourcing your thinking to the machine, right? So you're not really learning. You're just you're just outsourcing it to someone else, right? Now that being said, there are ways in which you can use AI to become better and to improve. And so those are topics that really interest me. So I use AI heavily, but I am very much against, and I discourage people from using it uh, using it as a handicap, right? Using it to so being lazy, for example, just outsourcing work to AI. AI should make you a better person. It should improve your reasoning and your thinking and your logic, and the quality that you produce should be better, right? And if you do that, then you're being responsible. You're using AI responsibly, right? So another fun topic. I can go on and on and on. I'm always keeping up to date with the latest and using it. I've got some friends who are also into this, and so we often meet up once or twice a week and discuss all the latest and greatest technologies and how we can use it to improve our lives. So very fascinating conversation. If you have any specific questions about that, I'll be happy to answer them.
Any other question?
Sorry, I didn't hear you properly. I think Maria.
Okay, you have a long day. Maybe we need to wrap it up, and be ready for tomorrow's session. You did a great job. And the good news of these sessions is that they are recording, and what we see the pattern is that the students go back again to the recordings and they do the exercise, and they have that self-learning. That is what I think will happen also with these sessions. They are less proactive and much more passive in terms of asking questions, but they go back to the recordings. So thank you so much. Well, they were really very nice and very deep insights we have, and truly practical techniques you have taught us. So thank you so much. We'll see you tomorrow, all of you. Thank you so much.
Bye, everyone.
Thank
Thank
you.
you.
Bye.
Bye. Thank you
Nice.
very much.
Bye.
Bye bye. Thanks.